Dear students, good morning to everybody. And today in this session we are going to learn energy and its types. So what is meant by energy? Energy means it is the ability to work or capacity to work or the amount of energy possessed by a body is equal to the amount of work it can be do when energy is released. And energy is a scalar quantity. Why? What is scalar quantity, my children? Scalar quantity means the physical quantities which have only magnitude but no direction are called scalar quantities. So energy has no direction because it is called scalar quantity. And the SI unit of energy is joules or J. And CGS unit of energy is erg. 1 joule equal 10 power 7 erg or 1 erg equal 10 power minus 7 joules. So what are the different types of energies? My children, mechanical energy, heat energy, sound energy, electrical energy, nuclear energy, and potential energy and kinetic energy, light energy, chemical energy, magnetic energy, etc. And these are the different types of energies. Now what is potential energy? Potential energy is defined as the energy of a body due to its position or change in shape. Example, the raised hammer possesses potential energy. So work driving the nail into the wooden block is done by the hammer when the energy is released. The water stored in a overhead tank possesses potential energy. Water when released is made to flow. Work is done by this potential energy. So potential energy is stored in a compressed spring. So children, these are the examples for potential energy. When the spring is released, the potential energy stored in the spring does work on the ball and the ball starts moving. Potential energy is stored in a stretched catapult. When released, it does the work of firing the stone. Formula of potential energy, my dear children. Suppose a body of mass m is raised to a height h above the surface of the earth against the acceleration due to gravity g. The work done in lifting the body against the force of gravity is given by, so work done equal to force and displacement, therefore W equal to mg into h. W equal to mgh. And this work done is stored in the body in the form of potential energy, therefore potential energy Pe equal to mgh. So potential energy is a scalar quantity. Why it is called scalar quantity? Because it has only magnitude but no direction. But it is to be taken with the proper plus or minus sign, depending on whether work is done against the force by or by the force. So potential energy is path independent. That is, it depends on the net vertical displacement height of the body but not on the path through which it is raised. Potential energy is a round trip, that is over or closed path is zero. Potential energy gained by the body, that is plus mgh. Potential energy lost by the body is equal to minus mgh. Total PE is round trip is equal to plus mgh is equal to mgh minus mgh equal to 0. Therefore, gravitational force is a conservation force or conservative force. Next, kinetic energy. The kinetic energy defined as the energy of a body due to its motion. Any object is in motion, we can say it as kinetic energy. Moving ball, flowing water, flying birds, or flying aeroplane, or running a person. And these are the examples for kinetic energy because they are in motion. Every moving body possesses kinetic energy. Example, a moving cricket ball possesses kinetic energy. When a cricket ball is moving, it possesses kinetic energy. Almost all moving objects will possess kinetic energy. So energy moving part in this engine possesses kinetic energy. So energy moving in this part, every moving part in the machine or engine possesses kinetic energy. So formula for kinetic energy. Suppose a body of mass m moving with a velocity u is acted upon by a force F for time t. Let V be the final velocity and S be the displacement of the body at the end of the time. The work done by the force is displacing the body is given by work done equal to force to displacement. Therefore, W equal to F into S. So, F equal to ma already as per the Newton's second law of motion, F equal to ma. So, in place of A, we can substitute ma equal to S. So, m is equal to A into S. We know that V square is equal to U square plus 2S as half into V square minus U square. Substituting for as in equation 1, W equal to m into half into V square minus V square, W equal to F into m into V square minus V square. Thus, work done possessed by the body in the form of kinetic energy, therefore, K equal to half into mv square, half into mv square minus V square. Therefore, if the body is initially at rest and its final velocity V equal to 0, then K equal to half into mv square. So note kinetic energy is directly proportional to the mass of the body and directly proportional to the square of the velocity of the body. If mass is doubled, K is doubled, and if the mass is halved, K is also halved. If velocity is doubled, K increases 4 times, and if the mass is halved, K reduces to 1/4 of its original value. Kinetic energy is always positive. Why? Because mass is always positive. Even if the velocity is negative, square of the velocity will be positive. Therefore, kinetic energy is always positive. So, kinetic energy is a scalar quantity because it has also magnitude but no direction. The term speed can be used in place of velocity in the formula for kinetic energy. Power. So, power is defined as the rate of doing work or consuming energy, or power is defined as the rate of conversion of one form of energy into another form of energy. Therefore, power equal to work done by time taken, P equal to W by T, or P is power equal to energy consumed by time taken, P equal to E by T. So, power is a scalar. S unit of power is watt. 1 watt equal to 1 joule per second. 1 watt is the power when 1 joule of work done in 1 second, or 1 watt is the power when 1 joule of energy is consumed in 1 second. 1 kilowatt is equal to 1000 watt, or 1 kilowatt equal to 1000 watt. 1 megawatt equal to, generally, children, 1 lakh watt, or 1 megawatt equal to, you observe here, 10 power 6 watts. Another unit of power is called horsepower, RHP. 1 horsepower is 746 watts. The power of engines of cars and other vehicles is measured by unit called brake horsepower, which is equal to 1 horsepower. So, commercial unit of energy. The commercial unit of trade or trade unit of energy is kilowatt, 1 kilowatt hour. 1 kilowatt hour is the amount of electrical energy consumed when an electric appliance having a power rating of 1 kilowatt is used for 1 hour. So 1 kilowatt hour equal to 1000 watt into 1000 watt. 3600 second equal to, observe here, 3600 kilowatts. Therefore is equal to 3.6 10 power 6 joules. So transformation of energy, my dear children, the change of one form of energy into another form of energy is known as transformation of energy. For example, devices, a body is thrown upwards, a body is dropped from a height above the surface of the earth, and filament bulb, electrical, and etc. Energy in first form, energy in second form, energy in third form. Energy first form, kinetic energy. Energy in second form, potential energy. And first form is potential energy, then kinetic energy. So, example, energy in third or fourth forms, sound, light, heat, if the body is stone or heavy metal falling on the earth's surface. Filament bulb, electrical energy, heat and light energy. Electrical energy, heat energy, also light energy is an indicator of fixed. So, these are the transformation of energies from one form to another form, my dear children. Just go through this table. Okay. So, thermoelectrical power, even for first chemical energy, heat energy, kinetic energy, and then electrical energy. So many changes takes place when if we use one form of energy, definitely convert into another form of energy. Now, law of conservation of energy. So, law of conservation of energy states that energy can neither be created nor destroyed. So, whenever energy changes from one form into another, the total amount of energy remains constant. When a body is thrown upwards or dropped from a height, the total mechanical energy, that is sum of the potential and kinetic energy at each and every point on its path, remains constant. Note that the highest point of its motion, the energy is fully in the form of potential energy, and at the lowest point the energy is fully in the form of kinetic energy. At all other points the energy is partially potential and partially kinetic. The potential energy is maximum and kinetic energy is zero at extreme positions. The kinetic energy is maximum and potential energy is minimum at the mean positions. Okay, children? So acknowledgements is given here. Thank you and have a nice day.